Good evening, everyone. It's my great pleasure to share my thinkings of the potential opportunities that the pandemic may bring us. I am Milin Zhang from Tsinghua University. I'm an associate professor in the Department of Electronic Engineering. My research interest focuses on low-power sensor interface and smart system designs. The unexpected COVID-19 changes our lives. In the past year, we all experienced a long time work from home, and the hospital and health systems struggled to manage patients more than it was designed to handle. Most of the social activities were cancelled. Last year, ISSCC2021 virtual, and same as this year. And CICC VLSS Symposium, ISSCC SCAR all went virtual. People thought the virus may disappear in summer and everything will go back to normal. But, after this winter, it's definitely not as we expected. Now it's impossible to predict what the world will look like next week, next month, or next year. But there is one thing we are now very sure about. Health is really very important to us. Although COVID-19 has presented many challenges for healthcare, it may also provide the biggest opportunities to the healthcare sector. There is no doubt that more attention has been emphasized on healthcare from last year. The VCs are more interested in talking to startup founders, focusing on new drugs, medical equipment, medical devices, or service or facilities. From the government point of view, according to the World Health Organization, even in a normal year, if globally 1% of GDP, that's globally about $200 billion a year, were spent into community-based primary care systems, over 16 million lives will be saved a year. And it also will increase the average global lifespan by 3.7 years by the year of 2030. In addition, more intelligent young kids will be attracted to the study of biomedical-related majors. According to the Association of American Medical Colleges, so the applications to medical schools were 18% higher this year than last year. So we all need good medical care for a healthy life. So every time when you go to a hospital or just take a regular ear check in a clinic, so the doctors use a lot of modern devices for reports before get to a conclusion. Take the electrocardiogram, for example. It's one of the most common tests in hospital. It's used by a specialist to evaluate the heart condition, and it takes the heart's rhythms and electrical activities using surface electrodes attached to the chest, the wrist, and the ankle. So the test usually takes only a few minutes, and then your heart condition is regulated digitally in your profile. This is so common to us. But do you know how did people do this 200 years ago? So in 1887, Wheeler used an electrometer to record the very first human electrocardiogram in human history. Surface electrodes were attached to the front and back of the chest. He attached his equipment to a slowly moving toy train to record the heart's activities in real time. Wheeler often demonstrates this device using his dog Jimmy, it's shown in the photo in the middle. When do the test, Jimmy would stand with one of its front paws and one of its back paws in two glass jars of saline. And the waveform we can see here at the bottom, well, it's somehow a little different from what we are familiar with, but the rhythm and shape are already very similar. Later in the early 20th century, William Einstein invented the very first modern electrocardiography. He developed a very high sensitivity string galvanometer for the measurement of the current action current of the heart. By using this device, he successfully recorded the very first high-quality electrocardiograms in 1902. This device was very bulky. It weighed about 217 kilograms, and it required a water cooling system, can you imagine? And it needed 5 people to operate. But anyway, this is a great work. Einthoven received the Nobel Prize in 1924 for this invention. If we compare this, as shown in the photo in the middle of the slides, to the modern electrocardiography that we have seen in the hospital, so we will find that the setup didn't change for 200 years. We still take the signals from the chest, and we still need the references from one of our upper limbs and one of our lower limbs. The biomedical theory doesn't change for 200 years. And then, what changed? In 1945, Norman Jeff Holter developed a wearable electrocardiography, as shown in the middle of the slides. So it consists of a very bulky ECG radio transmitter and very heavy batteries. I'm sorry to say that if for a patient with heart issue, I really don't think that he or she will be able to carry this. But this is one of the greatest technological achievements in the history of modern cardiography. Well, this changed in the 1970s. From late 1960s, Bruce and his colleagues developed a series of compact holters. Showing here in the middle of the slides is the photo of one of their typical model. Well, this is the model 445. It's a mini holter record, and it's about the size of a purse or handbag. The battery supported a continuous record of about 10 hours. In fact, there are over 20 holter companies registered in the United States from 1960s to 1970s. Well, nowadays, we have capsule-size implantable holters, and we can check the actual diagram in a wearable watch. And this is the life I think that people lived in 200 years ago can never imagine. Well, I mentioned earlier that the biomedical theory doesn't change for hundreds of years, but the methodology we apply to realize it changed a lot. It's only because the great improvement in assay technology, higher power efficiency and higher volume efficiency can achieved. That means with an even smaller and more compact device, we can integrate more functionalities and consumes much less power. And this trend doesn't stop. In fact, this trend is not only observed in the development of ECG devices, but also in biochemistry check and in bioimaging and in other bioelectronic detectors. In fact, that we have witnessed this trend in the recent years of ISSCC. So, for example, last year, Stanford Group proposed a biosensor to measure small molecule cracks in the whole blood for pharmacokinetics. Pharmacokinetics described what the body does to a drug, including the movement of a drug into, through, and out of the body. It has been studied for about 50 years. So what we are sure is that the drug PK can vary 30 to 80% among the individuals, but no one can predict it or continuously follow the entire process after a patient takes a drug. Well, in clinical research, if a specialist wants to study the PK for a patient, he has to take blood samples every few hours, and this is very inconvenient, and few people would like to volunteer in such a study. But I think the proposed biosensor by the Stanford Group last year changed this. It can be fully integrated, it can be fully implanted in the body of the subject. It's integrated a wireless data transmitter and consumes only 0.22 millivolt at a 5 Hz data acquisition rate. In fact, the minimization of bioimaging devices has also been widely reported in ISSCC2021. So, for example, bioimaging for skin cancer diagnosis. Well, according to the latest cancer facts and figures released by American Cancer Society in 2020, skin cancer is still the most common cancer in the United States and also globally. While more than 5 million new cases of skin cancers are diagnosed every year in the United States. Well, in fact, if it can be detected earlier, the 5-year survival rate can be as high as 99%. Well, if you go to see your doctor to check if you are risky to have a skin cancer, well, what your doctor will do? Well, your doctor may look at your skin to find out whether any part of your skin is with changes that are likely to be skin cancer, and definitely further testing is needed to confirm such a diagnosis. For example, your doctor may ask you to take an OCT imaging, and usually that may take you months to get an appointment. Or if the suspicious looking skin is really cancer, it may be already too late. But in 2019, the CAST group proposed a super compact skin imager. The size of the entire system is similar to a quarter size as you can see here in the picture. But the total weight is only 3 grams, and the imaging results can be simultaneously displayed in the mobile. The operation can be performed even at home. I would like to see this is a work that's going to save lives. In addition to biochemistry ICD lens and bioimaging ICD lens, ICD lens for bioelectronic detectors are the most common topics in IMMD. For example, in 2019, IMEC announced their latest ISO-CT lens for continuous vital sign monitoring. It integrated detections of the ECG and the bioimpedance and PVG. So for patients in hospital, the nurses keep checking the vital signs. So nowadays, there are a lot of electrical devices used in hospitals that enable automatic vital sign detectors. The nurses are happy, but I think most of the patients don't like it very much. Because every time that when the patient want to leave the room to have some fresh air, he or she has to ask the nurse to remove all the cables connected. And after he or she returns, the nurse has to reattach it to him or her. I think that definitely it will be great if the vital sign auto detectors can be wireless and lightweighted. It will be welcomed by both the patients and the nurses. All these wishes were met by the IMEC work in 2019. Of course, IMEC is not the first to try to design wireless vital sign detector, but they achieved the state-of-the-art performance in power efficiency and volume efficiency. The power consumption of the reported work is only 769 microwatt. A long battery life as long as to several weeks can be expected even only with a miniature battery size. Such a design can greatly improve patient comfort and reduce the cost of care, and it will release more hands in hospital. And after last year, I think everyone knows how important if there are more hands in hospital. And in 2016, UCLA group proposed a wireless neural interface, and the proposed design can be applied for the motor function recovery after spinal cord injury. Well, for years, ISSCC witnessed how IC technology changed the methodologies used in biomedical and clinical practice. What I mentioned are only examples from lots of such great jobs. Well, there is an old Chinese saying, a worker must first sharpen his tools if he wants to do well. And I believe we as designers can help the doctors to sharpen their tools by applying our expertise to the biomedical applications. IC Plus Medical a happier and a healthier life can be expected. Thank you for your attention.